properties of scalar triple product. The first property is if A, B, C are the three vectors and they are cyclically changed, then the value of scalar triple product remains same. What does it mean? We know that scalar triple product is nothing but the box product of vectors A, B, C, right? Now, this property tells us that if they are cyclically changed, what does it mean? It means that here A vector is in first position, B vector in second, and C vector is in third position. If you change it cyclically, means B vector comes in first position, C vector comes in second position, and A vector comes in third position. These two values remains the same. So similarly, this can be written as C, A, B, which means we are changing it cyclically. Now next, again, if you change, again you'll get the original this one, right? Again, A comes in the first position, B in second, and C comes in third. So if you cyclically change the scalar triple product, the value gonna remain same. The second property is the change of cyclic order of vectors in scalar triple product changes. When does it changes? This changes the sign of scalar triple product but not the absolute value. It changes the sign but the magnitude gonna remain same. This property tells us that if ABC a box product, then if we change any two values, like if A and B got interchanged like this and C remains the same as it is, then we'll get a negative sign over here because the scalar triple product is nothing but the determinant of these three vectors, right? So according to the properties of determinant, if we change any one row, we'll get a negative sign outside. So that's the reason we are getting negative sign over here. And this can be equal to, now let's change B and C. A remains the same, C and B, it can be interchanged. Again, here also we'll get a negative sign outside. Next, let's interchange A and C, B remains the same. For this also we'll get a negative sign outside. So if we change any two rows, then the sign gets changed, but the absolute value or the magnitude remains the same. Now coming to the third property. It's given like these are AB3R. Coming to the third property. It is given as A, B, C are the three vectors and scalars L, M, N are given. And the box product of L, A, M, B, and C can be written as all the three scalars can come out and inside the box product will be A, B, C. It's like just the determinants. Like you can take out the constant outside and you can do the determinant of the remaining thing. Fourth property tells us that the scalar triple product of three non-zero vectors is zero if any two vectors are equal, parallel, or collinear. Like if B vector is equal to C vector, then the box product of ABC becomes A, B, and C also becomes B because C and B are equal, and this becomes zero. Why? Because according to the properties of determinant, if two rows are identical, then the determinant gonna be zero. And the other reason also we can tell this scalar triple product can be written as A dot B cross B. I've already told you in the properties of vector product. If you multiply two vectors with using the cross product, you'll get the value 0 over here. So anything multiplied with 0, you'll get final answer as 0. So this is also a reason to get 0 as the answer if two vectors are equal. Next, if the two vectors are parallel or collinear, what does it mean? It means that if B vector is equal to some lambda times C vector, this is the property of parallel or collinear, right? Then we can write the box product of ABC as A. B can be written as lambda times of C and C. Here we can take lambda outside the determinant and we can write it as ACC. Again, this becomes 0 because two vectors are same. So finally, if any two vectors are equal, parallel, or collinear, the box product will be 0. The next property is box product of A plus B, C, and D will be. This can be written as A, C, and D plus box product of B, C, D. It's just nothing but splitting the determinant. So similarly, here it becomes just split all the three rows. Like if you take first A, then C, E. This will be the first box product plus. Just keep A and C as it is, and instead of E, write F. Now we have splitted the third row, right, into E and F. Now just split the second row like A, D, E. Again it becomes A, D, F. This is all about the first row, that is A. Now plus similarly write with B, that is B, C, E. Next it becomes B, C, F. Next B, D, E. Next B, D, F. So if you add all these values of box product, you'll get, it's nothing but these. So it's nothing, it's like just to split the determinants and all the three rows.